Okay, so now let's move on and talk about energy shells and how electrons are stacked into atoms. So the first question asks us to predict the ground state electron configuration of magnesium and silicon. So what we need to do is look at the periodic table and see how many electrons they each have. Magnesium has 12 electrons. And then we're just going to pack them into the cells. So we start off with N. So if N equals 1, we've got the 1s state. An S state can only hold 2 electrons. Okay, so I've got 10 electrons left. Next thing we do after N equals 1, N equals 1 can only have 1 S. Then we go to 2, N equals 2. N equals 2 state can have 2 S and it can have 2 P. So every S state can have 2. Every P state can have 6. So let's see, we're at 2 plus 2 plus 6. So now we're up to 10 electrons. And I've totally filled the N equals 2 states. Now I've got to go up to 3. Lowest energy state is S. And in the S state I can put 2. So that gives me my 12 electrons. Okay, how about silicon? Silicon has 14 electrons. So I need to put 2 more electrons in. So let's just go through in order. We're going to fill them the same way. So now I'm up to 12. The next thing I can do is the next lowest energy state is N equals 3, L equals 1, which is 3P. And I've only got 2 electrons left, so I can put it in there. So I'm going to have 2 electrons in the 3P state, and there's a possibility of putting 4 more into that state. So I could go higher up in the periodic table still filling the 3P state. All right, in this question now, we want to figure out which element corresponds to each of these electron configurations, and then think about whether they're excited states or ground states. So if I look at A, basically what I want to do is I want to add up how many electrons there are, and that'll tell me the atomic number, and then I just look it up in the periodic table. So I've got 2 plus 2 plus 5, which turns out to be 9 electrons. Okay, and this one I've got 2 plus 2 plus 6 plus 2 plus 6 plus 10 plus 2 plus 1. So let me see what I got. That's 10, 18, 28, 30, 31 electrons. All right, and in C, I've got 2 plus 2 plus 4 plus 1, so that's 9 electrons. Okay, so now let's go and look at a periodic table. So here's a periodic table, and I've got in A and C, I've got 9 electrons. So if I look at my periodic table, you can see an element with 9 is fluorine. And let's see, in B, I had 31. So that gives me gallium. So I've got fluorine, gallium, and fluorine. So I'll go back. This is fluorine. This one's gallium, and this one's fluorine. All right, next thing is, are these excited states or ground states? So it's an excited state if I'm not filling the shells in order. So if I look at A, I've got 1s2, that one's completely full. Then I filled 2s2, and then I do 2p5, and I can put up to 6 in there. Nothing is excited there, so this is a ground state. All right, let's look at gallium. So gallium, 1s2, 2s2, 2p6, right? That's completely full. Then I go to 3s2, 3p6. That's completely full. Next thing after 3p is 3d, and I can put up to 10 in there. I've got 10 in. Then I go to n equals 4, and the S shell is first with 2, and then p with 1. That's also a ground state. I've put everything in the correct order. All right. How about C? So C is fluorine, and you'll see that in C, if you compare it to A, what we've done is we've taken 1 electron from the 2p state from A, and we've bumped it up into the 3d state. So this one is an excited state. right? That fifth electron should be down in the 2p state, but instead it's sitting way up in the 3d state. So it's up by what, 3 subshells, right? It should be in 2p, and it's gone up beyond 3p into the 3d state. So that is an excited state.